video, we're going to talk about another application of dimension, which is derivation of the exact formula. So to derive exact formula of an equation. Now, the steps that are involved is number one, we can convert every given parameter to dimension. So the parameters that are given to you, first of all, convert them to dimension. Number two, simplify when necessary. Number three, introduce the missing dimensions to their deficient side, raising their power to 0, because anything you raise to power 0 becomes 1, so it will not affect the parameters given to you. Number four is equate same basis to obtain unknown powers. The next one is to introduce these obtained powers into the original equation that is given to you. Then you derive the exact formula. Let's look at an example now that we want to solve. Look at this question. This question says the period of oscillation t of a simple pendulum of length L is given by the equation t equals 2 pi m raised to power x, L raised to power y, g raised to power z, where x equals mass of the bulb, g gives us the acceleration due to gravity. So you now say obtain the values of x, y, and z, hence derive the exact formula of that simple pendulum. Okay, so let's solve this right away. The first step says that we should convert every given parameter to dimension. So the first parameter t is already in dimension, so that's t, seconds, time. The next one is 2 pi. 2 pi is unitless, it doesn't have any unit, so it is equal to 1. Now the next one is m. M is mass of the bulb, and it is mass of the bulb, and it is given by, it stands for m, that's the dimension. The next one is L. L talks about length, that's measured in meters, L, dimension. Then G, acceleration due to gravity, which is L t minus 2, that's acceleration. So now if we are to put everything back in that equation, we're going to have that t is equal to 2 pi, which is now 1, times m raised to power x, L raised to power y, bracket L t minus 2 raised to power z. That's what it will be. Step 2 said we should simplify it when necessary. So it is necessary now we simplify this. So we're going to have t is equal to anything you multiply by 1, it's still that thing. So m raised to power x, L, you can see L y, we have another L that has z, so L z, then t minus 2 times z will give you t minus 2z. So if we still simplify that further, we're going to have that t is equal to m x L, we have L and L multiplying each other, so we sum their powers, y plus z, then t minus 2z. Now, having simplified this, we move to the next step. Step 3 said we should introduce the missing dimensions on the deficient side, raising the power to 0. If you look at on the left side, we have only t there. So m is missing, L is missing. So we introduce m, raising it to power 0. We introduce L, raising it to power 0, and then we write the t there, which is also raised to power 1. Now is equal to m raised to power x, L raised to power L, y plus z, I beg your pardon, t minus 2z. Now equate the same basis. That's what step 4 says. So step 4 says equate the same basis. For us to equate the same basis, this is m, this is m. So m0 is equal to mx. What this thing means is that 0 is equal to x. So x, or you say x, is equal to 0. Now, the next is L. We have L raised to power 0 is equal to, over here we have that L is equal to y plus z. L is equal to y plus z. What this thing means is that we have that y plus z is equal to 0. Now, let's note that y plus z is equal to 0. Another way you can put it is that y is equal to z. Crossing this other side becomes minus, so minus z. So if we note this, we go to t. T has 1 on top of it. So let's write it so that we will not forget. Is equal to t minus 2z. Now, if we note this, it means that z, or let's just work on the power alone. If we work on the power, 1 is equal to minus 2z. If 1 is equal to minus 2z, if we make z subject of the formula, z becomes equal to minus 1 over 2. Minus 1 over 2, or you say 1 over minus 2. Whichever one, they are the same. Now, if this is z, remember that y, recall that y is equal to minus z. And we have now gotten the value of z to be minus 1 over 2. Therefore, we will say that y is equal to minus z. Z is minus 1 over 2. Therefore, y is equal to minus is plus 1 over 2. Since we've gotten that y is 1 over 2, step 5, let's introduce them back into that original equation. The original equation says t is equal to 2 pi m, x is 0, L is 1 over 2, that's y is 1 over 2, then g raised to power z is minus 1 over 2. Now, t, if we simplify this, we'll have 2 pi, anything raised to power 0 is 1, so we neglect it. L raised to power half, according to laws of indices, anything raised to power half is root L. Then this is minus, meaning it is under root g. Therefore, you can rewrite it and say that t is equal to 2 pi or root L over g. This is the exact formula. Thank you.